Can you please?
Oh, there you go.
Okay. Thank you, Ryan. It doesn't matter, I guess. Okay. So now that this is over, for this problem, they said that they were talking about iguanas. It was like the iguanas are cold-blooded organisms with their body temperature depending on the external temperature. Their natural habitat lies near the equator, blah, blah, blah. And the sun shines 12 hours a day. Iguana's temperature cycles during the day with a low of 75 degrees Fahrenheit at about 3 a.m. or T equals 3, and 104 degrees Fahrenheit at about 3 p.m. or T equals 15. So we know that basically between its highest, this is the lowest, between its highest and its lowest temperatures, there are 12 hours that have passed. So that's some info, extra info. Assume that the body temperature of the iguana is modeled by the following. We have this formula, and then we just need to figure out the constants A, B, C, and D, just like the last problem. So basically what I just did inferred patterns from the last problem, and when I was looking, I discovered that like D is equal to the average, because like this is where the this is the axis where like the sine function or the cosine function is like oscillating about. So I basically just said that D, just like the last problem, it would be the average. So here I figured out the average by just minimum plus maximum divided by 2, because they only gave us 2 values. And unlike the other problem I actually like added every single value and then divided by 12, because there was like 12 months. So I got 89.5, and now I know that this is my D, or this is like basically like the new vertically shifted x-axis. So it shifted up by 89.5 units. And now I also figured out A, because when I looked back here, I saw that A, or the amplitude of the graph, is just the distance or the number of units between your average and the point, and the highest point on the graph. So, or the lowest, doesn't really matter. The amplitude is going to be the same because it's symmetric. So here I got basically what I did was I just got my maximum value, and then I subtracted my average, just like I did here. It was my maximum value, which was 74, minus my average, which was 66, to get my amplitude. And the same process, I got an amplitude of 14.5. So these were the two easier constants, and that was done. Now for my period, I know that cycles, like it said that the temperature of the iguana cycles throughout the day, and we all know days are 24 hours. Oh, sorry, days are 24 hours. So I said that my period, which is 2 pi over b, is equal to 24. And then using algebraic manipulations, got b equals pi over 12. So that's gonna be my period. And then lastly was just my what is it called? My horizontal shift, like along the x-axis. And so what I remember, well, actually, first of all, let's remember how a cosine graph looks like. Unlike cosine graphs, sine graphs actually start from 0. So you go 0, and then let's say this is 1. 0, 1, 0, -1, 0. So it looks something like this. Here I don't know what the temperature, where's the temperature at like this point per se, or like at 0. I do know it here, right? Also here it's not gonna be exactly at 0. It's gonna be somewhere like that, and it's gonna keep going before it like hits another because before it hits another, what is it called? Vertex. There you go. I forgot the word. So yeah, because I know that the distance between one vertex, this is a vertex here, and this is another vertex. So the distance between here and here between here and here is 12 hours. And obviously between 3 and 0 is not 12 hours, right? So I know that basically it's gonna hit a 0 or like a oh, sorry guys. Okay, yeah. So between here and between the vertices there are 12 hours that have passed. So I know that it's gonna hit a 0 between those two, like almost because it's almost exactly at a midpoint. So it's just like here, like between here and here, I have 2 units. So I have an x-intercept here, like between the two at one, like 1 unit apart from each vertex. Like basically, it's equidistant between both of them, between both vertices. So I looked at basically what 6 hours after like 3, it's 9. Ignore the fact that it's here. Let's just imagine that it's here. This is a rough sketch. So basically all I said that it was shifted 9 units, so that I know that this was supposed to be like the 0. Was supposed to be like the temperature at 0, but the whole graph was shifted 9 units, so that this is like my new like 0, like my not 0, my new y-intercept. How can I phrase this? Andrew, you want to chime in?
What are you trying to phrase?
I'm trying to say that like so I know that that there's an x-intercept between here and here, between one vertex and another, and
Okay.
mine is gonna be in the middle. And basically, this is my new, like, I want to explain why it got shifted like 9 units to the right. So yeah, like this is my new y-intercept basically. I mean my new y-axis.
Okay. I know what you're trying to say. Well, the time difference between 3 and 15 is 12 hours, and like halfway between that is going to be where it hits 0, and so like that's how you figured out the 9. But like the reason why it shifted over 9 is because sine graphs start at 0, and so if you're to like start this graph at 0, yeah, I guess this is kind of like hard to explain, but you're basically shifting the whole graph
9 units.
over 9. I'm like, it's like I'm explaining it with it's like looping back in its own explanation, you know.
Okay, I mean,
Alright.
if she's in this is a calculus class, so I'm just gonna assume she knows trigonometry.
All right. Either way, the sine graph has to start at 0, and that's where that's where the mid, like the average temperature is going to be, and so you find that point. But you'll notice that sine graphs start by going up, and that's why you don't start with the previous one that hits the middle over there, over at the left circle. Yeah. So
This is nothing. This is like not where it's done.
yeah. But she might be like, I don't know, maybe why didn't we choose that one?
Well, okay, because
Basically the horizontal shift is 9 because
here, I'll just
0 there. Yeah.
okay, a second. Like this way, whatever. This is like the end of the word, but anyways. So basically, this is not actually anything. This is not a 0. This is like at my, actually, it's not even gonna go through there. I don't know why I drew it like that. It was my here.
Yeah,
Like this
yeah, yeah.
actually goes somewhere like that.
Yeah, it's hard. It's hard because I can't like draw on here,
I know.
and the graph's kind of. Yeah, yeah, yeah. That's better.
Yeah. So it looks more like this. There you go. Let's hope this one makes sense better. So yeah, because here, as you can see, oh, okay, I'm starting to like erase things now. So like this thing actually starts like my next one. Let's just extend that line. So my x-axis is like here, but who cares about this point here? Because obviously you're not gonna have like an iguana be negative temperature, because then it'll die. But yeah,
That's negative time though.
yeah, our new 0 starts at 9. Our new 0 starts at 9.
Yes.
Yes. There we go. Hopefully that makes some sense. Yeah, that's why I was trying to like, that's why it took me so long to actually record this one, because I was like, I honestly don't know how to gonna explain this. I'm just gonna wing it. But yeah, I think it worked out.
I think it's easier to see if you draw just a single sine wave from start to finish on like a regular axis.
Yeah, I mean, I tried.
Yeah. Just like that. And then taking that whole thing, shifting it over 9 would be pretty much exactly what you see down there.
Oh, that's true. That's true. Because oh wait, what am I doing? Anyway, yeah. So like taking this guy and then shifting it like 1, 2, 3, like that.
Yeah.
But I guess it's stretched. That's why it doesn't look a lot.
Yeah. Just scale it in your mind and it'll be exactly like down there.
We love your explanation, Andrew. Here. But yeah, this is it, I guess. Hopefully that makes some sense.
So you got all the variables.